Okay, so today I'm going to prove by contraposition that if n to the fourth is odd, n is also odd, and that's assuming that n is an integer. So we need to recall that contraposition is written as, so we have P implies Q is the equivalent to non-Q implies non-P. Okay. So from there, we can make our P's and Q's. So our P will be n to the fourth is odd, and our Q will be n is odd. N is odd. So non-Q would just be n is even, because if a number is not odd, it's even. And we'll say non-P would become n to the fourth is even. Okay. So now our new statement would be written as, if n is even, n to the fourth. Well, we'll put then, because if-then statements make more sense. So then n to the fourth is even. Okay. So from there, how are we going to prove that they're even? So we can say by definition of even integers, I'll just say ints. So because n is an integer, which we said above, right here, we can say that n can be written as 2k for any k integer. Okay. So if n equals 2k, we'll have, so our statement would be 2k, and on the right side we would have 2k to the fourth. And then we need to prove that they are both even. Okay, so obviously this one is even because it's actually the definition of an even integer. However, we will have to simplify this one to prove that it's even. So to simplify, we will get 16k to the fourth. And to prove that it's even, we'll factor out a 2. Factor out a 2, and we'll have 8k to the fourth. So let's say we have another integer j. J equals 8k to the fourth, and j is an integer. Then our new statement becomes 2j, which is 2j is obviously an even integer because it matches up with 2k, because k is an integer, j is an integer. Okay, so what we just proved, let me see, proven, we proved that if n is even, n to the fourth is even, because we were able to simplify that to the definition of an even integer, and this one was already the definition of an even integer, so they're both even, obviously. So that's what we proved, which in turn, so I will say this also proves the contraposition. Well, this also proves, so that was our contraposition. We will say that this proves the original statement to be true. And our original statement was, if n to the fourth is odd, n is odd. And that's my proof. Thank you.